Okay, we're coming up to, we're finally making some headway. We're almost through ionic naming. The thing that we haven't talked about yet, but that we'll talk about now, is naming and writing formulas for transition metals. They're the ones that are a bit hard to pin down, so we've left them till the end. So transition metals are almost all the metals, right? It's a huge block in the middle of the periodic table, and as it turns out, that chemically they're fairly exciting. They do lots of different things. They have transitions, right? They can change. So in group 1 and group 2, if we go back and look at our very first periodic table, the reason why we were so excited to look at group 1 and group 2 first, and then even ultimately aluminum, is because, as I've been saying again and again, they have fixed charges. These have to be their charges. They cannot change. So chemically, they're pretty boring, but that means that they're very predictable. So they never change, and that's really good. Transition metals have multiple states of ionic charge that they can sit in. So if we look at if we just look at manganese, right? You can't maybe make these out very well, but manganese can have a +7, a +4, a +3, or a +2 charge, right? It's why it's called a transition metal. So it can have multiple ionic charges. That's a problem for us when we're naming it, right? These guys couldn't have multiple. Everybody over here was +1. Everybody over here was +2. Aluminum was +3. We'll come back to that guy. Everybody here to the stairs, right? These stair cuts, these charges always applied. They were fixed. And now we have these multiple ionic charges. I'm going to tell you which ones we tend to focus on here. But let's go over here and look at this grayed out block for a second. We said in an earlier video that aluminum we would treat as a fixed charge, and we listed it when we talked about group 1, group 2, and I also said aluminum, right? And so we treat all those metals the same. It turns out that you're going to have to also memorize the ionic charges associated with zinc, cadmium, and silver. They come up quite a bit. Gallium and indium, I know their names aren't here, but gallium and indium we don't tend to use, but they do follow, right, the same pattern as aluminum. So they tend to be +3. But we're not going to use those often in the course. For now, you have to know that zinc always carries a +2 charge, right? Cadmium carries a +2 charge, and silver always carries a +1. That's for you to memorize as well. Okay, now, if I am to use nickel or copper, right, these are big ones, nickel, copper, cobalt, iron, manganese, chromium. Sometimes we use lead and tin and antimony. I could use bismuth. I don't tend to use any of those. Yeah, that's pretty good. Titanium. If we use those metals, I do not expect that you would memorize these charges. Moreover, even if you did memorize those charges, it wouldn't help you with naming. So we just have to know that when we come upon a metal that lives in this general transition block, right, that we have special rules about how to name it, and that's what this video is going to focus on. So let's take a look. Let's go back and have an example. Now, I'm going to show you a name, and you're going to build the formula because we need to introduce this new concept for ionic metals, or I'm sorry, transition metals. So let's say that the name is iron Roman numeral 3 chloride. This is the first time we're seeing a Roman numeral. This is the thing that makes the ionic naming so different. This Roman numeral tells us the charge on that iron, right? So the Roman numeral has to be given for those transition metals, right? Has to be given. And that Roman numeral tells us the charge on the iron. So we know what kind of iron we have. We could have had +2 iron, right? If we went back and looked at this periodic table and we looked at iron, iron could be +2 or +3. You can't know what kind of iron it is until we tell you. So if this name had just said iron chloride, right? We cannot answer that question. That is an incomplete or erroneous name. So we have to show this Roman numeral if we want people around us to know what we're talking about. That Roman numeral is key. So if I want to come up with the name, if I want to come up with the formula, I need the same two things I've always needed. I need the symbol and I need the charge. Now, so we'll go get those, right? Now, chloride. I see IDE. I know that this is probably going to be binary. And we are probably going to go get it off the periodic table, right? Periodic. Okay, you know what I mean. You know what I mean. Periodic table. So we need that guy's symbol and charge. Now, we would go to the periodic table simply to find iron's formula. We're not going to find his charge there, right? I would go and find iron. He's Fe. I could put that back, right? I could say Fe. I don't have to get his charge off the periodic table. I cannot get his charge off the periodic table. I must get his charge from this Roman numeral. So I know that this iron must be +3. Chloride, I go back to the periodic table, I find him in the halogens, and I know his charge is a -1. So I need his symbol and his charge. So I go back, and I have chlorine. Now I know I call him chloride, and he's a -1. These guys are not electrostatically neutral, right? A +3 and a -1 do not cancel. I take the number. It tells me how many chlorine I need to get. I take this number, it tells me how many iron I'm going to need, and if I want to then put all that information together to make the formula for iron 3 chloride, it will be FeCl3. Okay. So it's not that bad, right? We're using all the same rules that we used before. We're finding the symbol and charge. It's just that the symbol comes in a different place for an ionic, for a transition metal. So let's try another one. How about copper 2 sulfate? Okay, so we look at copper 2 sulfate. We see this Roman numeral that tells us the charge. It also tells us that this must be a transition metal. Only transition metals carry Roman numerals, right? Group 1, Group 2 aluminum, we never used a Roman numeral. So only transition metals need Roman numerals. So we know that we have his symbol and his charge, right? He's Cu, and he must carry a 2+. Now, I go over here, I read this name, sulfate, that ATE tells me to go to my polyatomic list because it's ending in ATE or ITE. So I'm going to go look for sulfate, the name, right? And I'm going to come up with the formula and the charge. I need the formula and the charge. So I'm going to go back over to my list. I'm going to keep looking up and down the names till I see sulfate. My formula is SO4. My charge is a -2. SO4, -2. So I write that down. SO4, -2. Now, I can see that this time they are electrostatically equal. So they are going to come together and their charges will cancel. So all I need to do is take their formulas and squeeze them together. So the formula at the end of the day is going to be Cu SO4, I don't need any subscripts because they canceled out, and that's copper 2 sulfate. So not so bad when you know what to do with this Roman numeral, right? As long as we know what to do with that guy, it's not a very complicated process. So we only have one more thing left to do. So there'll be one more video after this, and then you'll have examples of every kind of naming in the Ionic world. So stay tuned for that.